Jai Hind students, welcome to my YouTube channel. Students, the true nature of happiness is not known to man. In my considered opinion, happiness, it has to be earned. One has to earn happiness. Actually, give happiness to other folks and get joy in return. So students, keep spreading happiness, right? Okay, so let's start today's session. We have already done 5 cases of projectile motion. It's basically projectile motion is an example of motion in a plane. That is, it's a 2-dimensional example, right? So today in this session, we'll be discussing the projectile motion on an inclined plane. So this is case 6. We will discuss projectile motion on an inclined plane, right? So in this particular topic, we will try to derive the expressions for time of flight, the range along the inclined plane, the range along the horizontal, the maximum height above the inclined plane, and the conditions for which the range on the inclined plane may be maximum, right? So let's start with the topics. So let's first concentrate on the diagram, right? This is suppose the ground, and let us consider this to be the horizontal plane. This is a horizontal plane, and suppose it is making an angle alpha. So this is an inclined plane, and this is the ground. This is the ground, which can be considered to be the surface of the earth, and this is the inclined plane. This is an inclined plane, and as per the diagram, what we have considered is, we have considered inclined plane to be making an angle alpha with the ground, right? This is the horizontal. Now suppose this is point 2. What we consider is, let's consider along the inclined plane to be the x direction. Let us consider this to be the x-axis. OX is the x-axis along the inclined plane. Obviously it is not horizontal. Horizontal is along this. So OX over here do not represents horizontal direction. It represents along the plane, along the inclined plane, right? So this would be y-axis. This is y-axis, right? This is x-axis and this is y-axis. Obviously the angle between them is 90 degree. Now from point O, a body is projected, say with velocity u, making an angle theta with the ground. Making an angle theta with the ground. This entire angle is theta. This entire angle, it is theta. So students, theta is the angle which the direction of motion of the projectile makes with the ground. So what will be the angle which it makes with the inclined plane then? It will be theta minus alpha. It will be theta minus alpha. Look, alpha is the angle which the inclined plane makes with the horizontal. Theta is the angle which the direction of motion of the projectile makes with the horizontal. So the angle which the velocity vector of the projectile makes with the inclined plane would be obviously theta minus alpha, as it's pretty evident from this diagram. So obviously the projectile will follow a parabolic path like this. It will follow a parabolic path like this. So it will strike the inclined plane, say at point A. And if you draw a perpendicular over here, say this is point B. And let us consider this to be t equals to 0. This is the highest point, right, of this projectile. This is the highest point. So it will be equal to t equals to capital T by 2. Capital T would be the time of flight. Remember students, time of ascent would be equal to time of descent. And this is the total time of flight over here. Capital T would be the total time of flight. Clear students? Capital T is the time of flight, means the total time during which the projectile will remain in air or space. So this is it. This is the diagram. This is the inclined plane. So there shouldn't be any confusion. This is the inclined plane. Right? Now what we do is, remember students, just let's compare these two diagrams, right? let's compare these two diagrams. This is x-axis, this is y-axis, this is velocity u, and suppose this is angle theta. So it tends to follow a path like this. This is t equals to 0, this is t equals to capital T by 2, and this is t equals to t. So in this case, OX represents along the horizontal, right? What's the difference between these two? Just try to make out the difference between these two. Here in this diagram, alpha is equal to 0. Nothing else. So this entire coordinate system is being oriented by an angle of alpha in the anti-clockwise direction. It is first x-axis and y-axis. It was like this. Now the coordinate system is oriented by an angle alpha in the anti-clockwise direction. So that's the only difference, right? Otherwise, while deriving the expressions for these terms, we'll be making use of the same concepts, right? Here, we will discuss about the acceleration due to gravity. Now we are aware, students, the acceleration along the horizontal direction is always 0. Along this direction is always 0. But along the inclined plane, it will have some acceleration, isn't it? So let's try to find it. So again, concentrate on this particular diagram, students. Please concentrate on this diagram. This is alpha. This is any arbitrary point. Now acceleration due to gravity, its direction is always towards the center of the earth in the downward direction, right? No doubt regarding this. Now what we have considered is, if you draw a parallel line over here, parallel to the horizontal, and this is suppose the vertical line, okay, since this is alpha, this is the angle which the inclined plane makes with the horizontal, so this one would be also alpha. These are two parallel lines, this will act as a transversal, so these are the pair of corresponding angles, right? Now what to do is, drop a perpendicular over here, like this. This is perpendicular to the inclined plane, right? So if this is alpha, this remaining angle would be 90 minus alpha. This angle would be 90 minus alpha. Therefore, this is vertical, this is horizontal, and this is vertical. So this remaining angle would be again alpha. So what I mean to say is that, students, if you consider any arbitrary point on the inclined plane, this is any arbitrary point on the inclined plane. So this is G, this is alpha, this is considered to be the x-axis, and this one is considered to be the y-axis, right? So this angle would be also equal to alpha. This is what I proved over here, right? So now this G can be resolved into two components. One along the negative y-axis, this would be G cos alpha, while the other along the negative x-axis, this will be G sin alpha. This was considered to be x-axis and this was considered to be y-axis, right? So now let me tell you some very important facts which we'll be considering over here. First and foremost, first point, in an inclined plane, you need to remember all these points, right? Before we start with the derivation of the articles for those terms. So here, acceleration along OX, that is acceleration along X direction. OX is along the inclined plane, it's not along the horizontal. Along the horizontal, students, acceleration is always 0. But here, OX is not horizontal, it is along the inclined plane. So here, acceleration would be equal to minus G sin alpha. Why minus sign? Because G sin alpha is directed towards the negative x-axis. So the acceleration along the positive x-axis would be minus G sin alpha. Clear, students? It's pretty evident from that particular diagram. Okay, similarly, second point, acceleration along OY. Acceleration along OY. Now, acceleration along the negative y-axis is G cos alpha. Therefore, acceleration along the positive y-axis would be minus G cos alpha. acceleration along the positive y-axis would be equal to minus g cos alpha. So these are two very, very important points to be noted down, right? Okay, now also the velocity component along OX, velocity component along OX, that is UX. Now you can resolve U into two perpendicular components, one along this direction, along the inclined plane. It would be U cos theta minus alpha, right? The other component would be along, the other perpendicular component will be along the positive axis, and it will be equal to uy, it will be equal to u sine theta minus alpha. So the initial velocity component along the x-axis, it will be equal to u cos theta minus alpha, and velocity component along y-axis, as it's evident from the diagram, I'm talking about the initial component, it is u sine theta minus alpha. Clear, students? These are the points which you need to remember before starting the article. And if you are able to get yourself fully convinced regarding these steps, the entire article would be very, very simple, right? Now let's start with the expression for the time of flight then. Okay, let's consider this to be point O, A, B, and suppose this is point B. Now consider only this part, forget about the inclined plane, right? Consider about this part. Just imagine as if the coordinate system XY plane has been oriented through an angle alpha in the anti-clockwise direction. Nothing will change. So at the highest point, students, you are aware, at the highest point, the vertical component of velocity is 0, right? So here, the vertical component of velocity, that is along y-axis, is 0. No doubt regarding this. We have already used this fact in the previous so many articles. So again, I must repeat, the vertical component of velocity at the highest point, that is along the y-axis, is always 0. So we'll make use of this fact and we'll be easily able to get the expression for the time of flight. So let's solve it. So we'll consider the motion along y-axis, and we'll consider motion from O to P. So let's consider motion from O to P and along y-axis. Let's make use of the first equation of motion, and that is V is equal to U plus AT along y-axis, right? Along y-axis. So what do we do? O is the initial point, P is the final point. At final point P, the vertical component of velocity is 0. So Vy is 0. What about Uy, students? Uy is initial vertical component of velocity along y-axis is U sine theta minus alpha. Plus, what is Ay? What is the acceleration along Oy? That is y-axis. That is minus g cos alpha. Minus g cos alpha. And what about small t? From O to P, the body must have taken half the time of flight. That is, it is P by 2. So students, simply rearrange the terms and you will get the expression for the time of flight. So what you get is, time of flight, it will be equal to 2u sine theta minus alpha divided by g cos alpha. So students, this is the expression for the time of flight of a projectile on an inclined plane, right? This is the first important result. Now students, how to verify whether the formula which we have derived is correct or not? How to verify it? How to cross check it? So for that, what you do is, suppose alpha is 0, then this case 6 will get converted to case 2, which we have done earlier, right? in case 2, when the body is projected with velocity u making an angle theta with the horizontal, then the time of flight is given by 2u sine theta by g. You must remember that formula, right? So putting alpha equals to 0 over here, we'll get 2u sine theta. Cos alpha, cos 0 is 1. So we will get 2u sine theta by g, which is the formula for the time of flight, same as was in case 2. So thus, this verifies that the formula which we have derived for the time of flight for this particular case is perfectly okay, right? So that's it. This is the expression for the time of flight. Now let's find out the expression for the range. First, we will try to find out the range along the horizontal, and then we can easily get the range along the inclined plane, just by using common sense, right? So let's proceed with that then. Okay. First and foremost, let's try to find out the range along the horizontal. Range along the horizontal, along OB. OB is the range along the horizontal. OB, it is the range along the horizontal. Let's try to find out this OB. For this, students, we need to consider the velocity component along the direction of OB, right? Now again, concentrate on this particular diagram. This is B, this is O, and this is the initial velocity vector U. It is making an angle theta, isn't it? This angle is theta as per this diagram. We need to consider the velocity component along the direction of OB. So if you resolve U along OB, then the component of velocity along the direction OB would be U cos theta, isn't it? So there's a golden rule. The velocity, which velocity component is to be considered? That velocity component is to be considered whose direction is along the displacement. So if you are considering the displacement OB, then we need to consider the effective velocity U cos theta along the direction of OB, right? Now this is horizontal, right? This is along the ground. Now along the ground, acceleration along the ground, it will be equal to 0. Remember always, projectile motion possesses two types of motion, horizontal and vertical. Horizontal motion, if it is parallel to the ground, then the acceleration along the ground is always 0. So OB is along the ground. So acceleration along OB is 0, right? So let's try to find its expression then. Okay, what to do is, over here. So OB, it is equal to, actually make use of second equation of motion from O to A. S equals to ut plus half at square along OB, right? Along OB. So S is equal to OB. U along OB, the velocity component is U cos theta. And from O to B, the projectile has taken time which is equal to time of flight, isn't it? Plus half. Acceleration along OB is 0 and t square. So this term, second term, gets eliminated. So we are left with OB is equal to U cos theta multiplied by capital T. Clear, students? So therefore, let's write the expression for the range along the ground. So therefore, I am writing it over here. Therefore, OB is equal to, which is the range along the ground, it will be equal to U cos theta multiplied by T. T is this one. Let's substitute the value over here. So what do you get? 2U square sine theta minus alpha and cos theta divided by G cos alpha. So students, this is the expression for the range along the ground. Clear, students? It's pretty simple. again I must repeat, I am considering the motion along OB, along the ground, right? Range along the horizontal. Horizontal means along the ground, OB. Along the direction OB, the acceleration is 0. Acceleration along OX is not 0. It is equal to minus g sine alpha, right? But along the ground OB, it is 0. So here we have made use of the second equation of motion along the horizontal, along OB. So u, that is velocity component along the ground, would be u cos theta. Total time taken by the projectile to reach from O to B, it will be time, capital T, which is time of flight. And A is 0 along OB. So we get OB is equal to u cos theta multiplied by capital T. So simply you need to substitute this value of T over here and you will get the expression for OB, which is the range along the horizontal. So this is second important formula, right? Now students, once we have got the expression for the range along the horizontal, we can easily find out the range along the inclined plane just by making use of common sense. It's a right angle triangle, isn't it? So what we can do is we can consider cos alpha. This is the right angle triangle which is subtending angle alpha over here. So cos alpha, it should be equal to base over hypotenuse. It is OB divided by OA. Therefore, what about OA? It is equal to OB divided by cos alpha. What is OA? OA is the range of the projectile along the inclined plane. Clear, students? So, therefore OA, it will be equal to OB divided by cos alpha. Simply substitute this value of OB. So what we get is 2u square sine theta minus alpha. Over here we will get cos theta divided by g. This is cos alpha and this is divided by cos alpha. So here we get cos square alpha. It is cos square alpha. So students, this is the expression for the range of the projectile along the inclined plane, right? So these are the three very, very important expressions. Now how to verify whether this formula so obtained by us is correct or not? Remember, if alpha becomes 0, then this will get converted into case 2, where the range of the projectile was found to be u square sine 2 theta divided by g. You must remember, isn't it? So here, let's substitute the value of alpha to be 0. So if it is substituted as alpha to be 0, then 2 sine theta cos theta will give us sine 2 theta. Alpha is 0, cos alpha, cos 0 is 1. So we will get u square sine 2 theta by g, which is same as that of the expression obtained for range in case 2. So you can easily justify whether the answer or the expression obtained by you is correct or not. So it's absolutely correct. Just now we have verified it, right? Just substitute the value of alpha equals to 0, then this case 6 will become case 2, right? Okay. So OB, remember student, OB is the range of the projectile along the ground. OA is the range of the projectile along the inclined plane. So in order to find out the range along the inclined plane, first find out the range along the ground. In that way, with a single step, you can easily find out the expression for the range along the inclined plane, right? Now what we'll do is, we'll discuss some special cases. What we'll consider is range. We'll try to find out the expression or the condition for maximum range along the inclined plane, right? So range along the inclined plane. And range along the inclined plane is considered to be OA. And that is 2u square sine theta minus alpha cos theta divided by g cos square alpha, right? Now let's try to rearrange this term. Look, we are aware of this formula. 2 sine A cos B is equal to sine A plus B plus sine A minus B, right? Let's make use of this trigonometric formula. This is in the form of 2 sine A cos B. It can be written as sine A plus B, sine A minus B, right? This is a trigonometric formula which we'll make use of in order to rearrange the terms. Therefore, range along the inclined plane would be given by u square sine A plus B. This is A and this is B. Theta minus alpha plus theta, that will give us 2 theta minus alpha, right? Plus sine A plus B. This is A, this is B. Theta minus alpha plus theta, it will give us 2 theta minus alpha. Plus sine A minus B. Theta minus alpha minus theta. Theta minus theta get cancelled. We'll be left with minus alpha divided by G cos square alpha. Clear, students? Okay. Sine we are aware. It's an odd function. Sine minus theta is equal to minus sine theta. So sine minus alpha would be equal to minus sine alpha. So therefore, OA, it would be equal to u square sine 2 theta minus alpha minus sine alpha divided by G cos square alpha, right? So this is another way of expressing the range of the projectile along the inclined plane. Now we can find out the condition for the maximum range. Now look, for a given inclined plane, alpha would be constant. For a given velocity of projection, u would be constant, isn't it? So for given value of alpha and u, that is for a given value of the angle which the inclined plane makes to the horizontal, and for a given value of velocity of projection, obviously alpha and u would be constant. So over here, R would be maximum, or rather OA, it would be equal to maximum if this trigonometric function sine 2 theta minus alpha is equal to 1. The maximum value of sine function is 1. So if sine 2 theta minus alpha is equal to 1. So this is the condition. So let's further evaluate this condition and get the desired result, right? Okay, let's proceed. Therefore, students, if you substitute this value of 1, this value of sine 2 theta minus alpha is 1. So maximum range along the inclined plane, it would be equal to u square 1, this value would be equal to unity, minus sine alpha divided by G cos square alpha. Now cos square alpha may be written as 1 minus sine square alpha. Now denominator 1 minus sine square alpha, it's in the form of a square minus b square. It can be written as a minus b into a plus b. So 1 minus sine square alpha may be written as 1 minus sine alpha into 1 plus sine alpha. So 1 minus sine alpha, 1 minus sine alpha will get cancelled. We will be left with 1 plus sine alpha in the denominator. So what we get is u square, it can be written as 1 minus sine alpha, and it is in the form of a square minus b square. It can be written as 1 minus sine alpha into 1 plus sine alpha. So students, the maximum range of the projectile along the inclined plane, it would be u square divided by g into 1 plus sine alpha. So this is the expression for the maximum range along the inclined plane. Now, when we will attain this maximum range along the inclined plane? It can be attained only when sine 2 theta minus alpha is equal to 1. Okay students, this maximum range of the projectile along the inclined plane is attained only when sine 2 theta minus alpha is equal to 1 for OA to be maximum, right? So for the range OA, that is along the inclined plane, to be maximum, this condition needs to get satisfied. Now, if we further evaluate it, we can easily find out the condition. So 1, it is equal to sine 90 degree. So comparing both the sides, what we get is 2 theta minus alpha is equal to pi by 2. So rearranging the terms, we get 2 theta is equal to pi by 2 plus alpha. Therefore, theta, it is the angle which the initial velocity vector of the projectile must make with the ground. So it must be pi by 4 plus alpha by 2. So students, this is a very important result. So if the projectile is projected at an angle theta with the ground on an inclined plane, then its range on the inclined plane will be maximum. So this is a very important result, and this is the expression for the maximum range along the inclined plane, right? So now let's find out the expression for the maximum height above the inclined plane. So this is also very simple. We have to consider the motion along OY. What we need to do is, this is to be obtained, this one. This is the maximum height above the inclined plane, right? Above the inclined plane. For this, students, let's consider motion from O to P. Okay, now let us find out the expression for the maximum height. Expression for maximum height above the inclined plane. Above the inclined plane. So for this, we need to calculate the value of h. So consider motion from O to P and along OY, along y-axis, right? So let's make use of the third equation of motion. Third equation of motion is 2as is equal to v square minus u square, and we are considering the y component. So 2ay sy is equal to vy square minus uy square. So twice acceleration along y-axis, right? Just try to recall. At this point, this is the direction of small g, right? It can be resolved in two components. One along the negative x-axis. I've told you this is same as that of alpha, right? This is alpha, so this component would be g cos alpha, and this component would be g sin alpha. So the acceleration along the negative x-axis is g sin alpha. The acceleration along the negative y-axis is g cos alpha. So the acceleration along the positive y-axis, that is along OY, would be minus g cos alpha. So AY is minus g cos alpha. SY along OY, the displacement covered in moving the projectile from O to P, it's equal to h. Vy, it is the final component of the velocity along y-axis at point P, which is 0. Uy square, initial component of the velocity along OY, it's u sin theta minus alpha. So it will be u sin theta minus alpha and whole square. Right? So let's evaluate negative, it get cancelled. So h, it is equal to u square sin square theta minus alpha divided by 2g cos alpha. So students, this is the expression for the maximum height of the projectile above the inclined plane. So this is also a formula which you can actually cross-check whether the expression obtained by us is correct or not. As I told you, substituting value of alpha as 0, we will revert back to case 2, right? So we should get the same expression for the maximum height attained as was obtained in case 2 if we substitute the value of alpha as 0. So if you substitute alpha as 0 over here, cos 0 it will be equal to 1, so we will be left with u square sin square theta divided by 2g, which is exactly the same as was the expression obtained for maximum height in case 2, right? So these are the various expressions. Here, one thing I would like to mention is that here we are dealing with the case of projectile motion up on an inclined plane, up on an inclined plane. In case it was the projectile motion down an inclined plane, then alpha in the expression for time of flight, range or maximum height would have been replaced by minus alpha. So this is up an inclined plane. In the case of down an inclined plane, alpha would have been replaced by minus alpha. So for that you need not to remember these expressions in a new way. Just remember these formulas, right? And then make use of your common sense. This is the case of projectile motion up an inclined plane. In the case of projectile motion down an inclined plane, alpha in these expressions will get replaced by minus alpha, right? Okay. I will explain what I have told you right now. This was the case of projectile motion up an inclined plane. Now what we need to do is, suppose this is the case. This is an inclined plane. Let us consider this to be an inclined plane. This is the origin. This can be considered to be x-axis, right? This is alpha. And this may be considered to be y-axis. This is the vertical, perpendicular to x-axis. This can be considered to be the y-axis, like this. Now here, a body is projected with velocity u, and this is parallel to the ground. This is parallel to the ground. This is angle theta. Now if this is alpha, this one would be also equal to alpha. So it will follow a path like this. So this is the case of down an inclined plane, right? In the previous case, it was up the inclined plane. Here, the expressions for the time of flight, range and maximum height can be obtained by replacing alpha by minus alpha. Substitute alpha with minus alpha, and that will give you the expressions for the time of flight, maximum height and the range. Clear, students? It is the case of projectile motion down an inclined plane. Clear? So here the orientation of alpha will get changed. The total angle, here the total angle along the inclined plane would be theta plus alpha. So theta minus alpha, that will become theta plus alpha. Right? One more thing, students. Let us revise all the formulas which we have derived in this section and compare it with the formulas derived in case or in article 2. Okay, this is the case. This is considered to be alpha. This is theta, total angle, and this angle is theta minus alpha. Right? This is case 6, which we have just now discussed. And case 2 was like this. This is velocity of projection u making an angle theta with the ground, which is considered to be x-axis. Okay. Clear, students? Here the expression for the time of flight is 2u sin theta by g. Right? Second, the expression for the maximum height is u square sine square theta divided by 2g. And third, the expression for the range is u square sine 2 theta divided by g. Clear? We have obtained all these expressions in case 2. Now let's consider this case. Here the time of flight is 2u sine theta minus alpha divided by g cos alpha. Now look, what's the change? What's the difference in these two? Here alpha is equal to 0. Now substitute the value of alpha as 0 over here. Cos 0 is 1. Theta minus 0 would be theta. So you'll get the same expression, 2u sine theta by g. Are you all convinced now? It's so very simple. Okay, second, maximum height attained in this case. What we have derived is u square sine square theta minus alpha divided by 2g cos alpha. Again, put alpha as 0 and we should get this expression. Over here, cos 0 is 1, alpha is 0, so we get u square sine square theta divided by 2g. Simple. Third, the range. Here we have got the range as range on the inclined plane, that is 2u square sine theta minus alpha cos theta divided by g cos square alpha. Right? Again, here put alpha as 0. So what do you get? Alpha is 0. So cos 0 is 1. So in the denominator we will be left with g. And here it will be 2u square sine theta cos theta. And 2 sine theta cos theta is sine 2 theta. So we will get u square sine 2 theta by g. So I hope students, although we have derived all these expressions, but you can easily remember these formulas. And these are very important from comparative point of view. Right? So we are over with all the cases of projectile motion. I hope you will remember all the related and associated concepts. Right? So that's it for this particular session. From the next lecture onwards, I will devote 1 or 2 lecture completely towards numericals based on projectile motion. Right? So do join me in my next session. Till then, do take very good care of yourself. Thank you.